Now that we know how to find asymptotes, how to find holes, we're going to actually graph rational functions today. So if you look at that first example of g of x equals 3 over x minus 2, we're going to actually graph it by hand. So the first thing we want to do is we want to find the y-intercept. We're going to also want to find the x-intercept. We want to find the vertical asymptote, the horizontal asymptote, and then we also just want to make a quick extra table with a few values in it. So I intentionally just listed those things next to my graph because I want to be able to kind of find all of those points, write them down, and then use them as reference points as I go to graph them, instead of having to look through all of my work and pick out what I need and keep scrolling back and forth back up to the graph. So in order for us to find the y-intercept, remember y-intercept is where the graph crosses the y-axis. That means our x value is 0. So we're going to take our function 3 over x minus 2, and we're going to plug in 0 for x. So we're going to 3 over 0 minus 2, which gives us negative 3 over 2, or negative 1/2. So our y-intercept is going to be 0 at negative 3 over 2. Then we want to find our x-intercept. And our x-intercept is where we cross the x-axis, so that's where y is 0. So now we're going to set the function equal to 0 and solve. So the first thing I have to do is multiply by the denominator on both sides. And when I do that, I end up with 0 equals 3, which we know 0 does not equal 3. So since there's nothing I can do there, that's a no solution. There is no x-intercept, which tells me that the graph is never going to cross the x-axis. If I want to find the vertical asymptote, I want to take the denominator, that x minus 2, and set it equal to 0. So I add 2, I add 2. I get my vertical asymptote is x equals 2. And then to get my horizontal asymptote, I have to use my rules. So I look and I say, okay, the degree of the denominator is 1. The degree of the numerator is 0. So the denominator has a bigger degree. Since the denominator has the bigger degree, my horizontal asymptote is at y equals 0, which also makes sense because I don't have an x-intercept. So now I know that my graph is definitely never crossing the x-axis, because the x-axis is the same thing as a line, y equals 0, and that's going to be my vertical asymptote. Then I want to just find a couple other points so that I know what I'm doing. But before I find those other points, I'm going to graph the things I know. So I'm going to draw in my x-axis. I'm going to draw in my y-axis. I'm going to put in my asymptotes. So my vertical asymptote is at x equals 2. So my vertical asymptote goes through here. My horizontal asymptote is at y equals 0. And I want to draw these in because they tell me where the graph can never pass through. So I know they're kind of like electric fences. I can't cross through them. I have to stay inside their bounds. So my graph either has to be up here or it could be over here and over here. But I can't have a graph that like passes through like this because it's getting zapped here and here. It has to stay within the confines of the asymptotes. So then I also see that I have a graph, or I have a point 0, -3/2. So my y-intercept is 0, -3/2, and -3/2 is just -1.5. So I know that my graph at least touches this point. So I just want to kind of plug in a couple more x values and get an idea of what's happening. So since I want to know what's happening around here, I'm going to pick a few x values there. I'm going to start with a -4. And I'm literally just going to plug it into the function. So I'm going to say 3 over -4 minus 2. -4 minus 2 is -6. And 3 over -6 is the same thing as saying -1/2. So when I go back 4, 1, 2, 3, 4, down 1/2, the graph looks like this. Then I'm also going to plot, let's fill in the point 1, see what it's doing on the other side. So when I plug in 1, I get 3 over 1 minus 2 is -1. So I get -3. So that means I'm over 1, down 3. And that tells me that this part of my graph looks something like this. So now I need to know what the rest of my graph is doing. I'm going to skip over 2 because I know that that's my vertical asymptote. So I'm going to plug in 3. When I plug in 3, I get 3 over 3 minus 2 is just 1, which gives me regular 3. So I'm up 3, gives me this point. Then I'm going to plug in 5. When I plug in 5, I get 3 over 5 minus 2, which is 3. 3 over 3 is 1. So I'm over 5, up 1. And I know, because rational functions are the same thing as my parent function, the reciprocal function, I know that that shape was generally going to look like before I started. So once I had a couple points, I could draw the graph connecting the rest of the dots. And now I have my whole graph, so I'm done. Let's give another one a shot, just to make sure we totally understand it. So we want to find the y-intercept. We want to find the x-intercept. We want to find the vertical asymptote, the horizontal asymptote, and we want to plug in a few more points after that. So first, to find our y-intercept, that's where we want to plug in 0 for x. So we're going to get 2 times 0 minus 1 over 0. This does not exist because we cannot have 0 in our denominator, so there is no y-intercept. In order to find our x-intercept, we're going to plug or set our whole function equal to 0. 2x minus 1 over x, and multiplied by x on both sides. Oop, running out of room. So then I get 0 equals 2x minus 1. I get 1 equals 2x. So x equals 1/2. So I have an x-intercept at 1/2 and 0. My vertical asymptote, I have to take my denominator, which is just x, set it equal to 0. So nothing there for me to solve, it's just x equals 0. And then my horizontal asymptote, I have to look at my degrees. My degree of my numerator is 1, My degree of my denominator is 1. So that means my horizontal asymptote is my leading coefficients, which are just 2 and 1. So my horizontal asymptote is just at 2. So now I'm going to draw my picture again so then I can kind of look at the graph and see which other values I want to plug in, see what I already have, see what I still kind of need in order to get the general idea. I see that I have a vertical asymptote at 0. My horizontal asymptote is up at 2. And I don't have a y-intercept, and I know I don't have a y-intercept because I also have an asymptote right down the y-axis, so that actually makes sense. But I do have an x-intercept at 1/2, 0. So I have an x-intercept right here. Okay, so I know my function, because I know that my rational functions normally reflect, the parent function reflects over the origin, so my rational function is going to be in quadrant 2 and quadrant 4. So I just need to plug in some points to confirm that. So let's see. Let's start with plugging in. Let's plug in like -3. When we plug in -3, I get 2 times 3, which is 6, minus 1, over -3. 6 minus 1 gives us 5 over -3. 5 over -3 is almost -2, but not quite. So when I'm back 3, this is a -6. Really a positive number, so when I'm back 3, 1, 2, 3, I'm up. Hold on. Wait a second. We plug in -3. Give myself a little more room. 2 times -3 minus 1 over -3 gives us -6 minus 1 over -3. There we go. -7 over -3. 7/3. 7/3 is really 2.33. So this is really 2.33. Which makes more sense because then when I'm back 3, 1, 2, 3, I'm just shy. I'm just right above my asymptote. So when I plug in -1, I'm going to get, let's see, I'm going to do it again down here. So I'm going to say 2 times -1 minus 1 over -1, -2 minus 1 over -1, -3 over -1, 3. So when I'm back 1, I'm up 3. If I plugged in a few more points, I could confirm, but I already know what my graph kind of looks like because I know what that reciprocal function looks like. So now I've got enough to draw in my graph. Then I'm going to skip over 0 because I know there's no points at 0. I'm going to be crazy and plug in 1/4 here. When I plug in 1/4, and I'm just picking numbers to kind of get an idea of what my graph looks like. So I already have a point over at 1/2, which is right here. So I just want to get a little closer to my asymptote. So I picked 1/4. So let's pick 1/4, and when we do that, we're going to take 2 times 1/4 minus 1 over 1/4. 2 times 1/4 is 2/4 or 1/2. So now I have 1/2 minus 1 over 1/4. 1/2 minus 1 gives me negative 1/2 over 1/4. And then I'm going to keep, change, flip, which gives me negative 1/2 times 4 over 1, which gives me negative 2. When I multiply straight across, I get negative 4 over 2, which is negative 2. So now I know that my function is going down this way. Plug in another point to confirm, but I can know that my function is going down like this. It's going to approach my asymptote, flatten out when it gets there. So now I have a graph completely filled in, accurate, because I've found a few points. My asymptotes are labeled and visible, so I'm done.